All right, so here we go. This is our last lesson of chapter 8. So we have 8.8 and let me get the volume up, okay? This is complex numbers. So the first part that we're going to study is the complex number system and I. The complex number system and I. So we're going to go back to the first lesson. You guys recall that the first lesson on classifications, and the only difference is we're gonna add one more of it. So we had this one, right? Which is the real numbers. That's what we had, correct? And we knew that the real numbers, we had irrationals and rationals, right? And inside the rationals, we had integers. And inside the integers, we had the natural numbers. Oops. Right? We had that. Now, the complex numbers. So which one are the complex numbers? They're going to be right here. Those are going to be the complex numbers. Okay? So the complex numbers are any numbers that can be written in the form of what? In this form, A plus BI. Those are the complex numbers. They can be written in this form. I think we could write them down like this, complex with a C. Now, let me just write something here. Real numbers. What are the real numbers? Real numbers are the rational numbers plus the irrational numbers, right? Now, the natural numbers, which is are part of the integers, and the integers are part of what? Of the rationals, and the rationals are part of the rationals and the rationals are part of the real numbers. All right, and the real numbers are part of the complex numbers. Complex numbers. Okay, so first we started with the real numbers. This is the rationals and the irrationals. Part of the rational numbers, we have the integers. Part of the integers are the natural numbers. And all of these are complex numbers. So we have the real numbers are rational and irrational. That the natural numbers are part of the integers, and the integers are part of the what? The rational numbers, and the rational numbers are part of the real numbers, and the real numbers are part of the what? The complex numbers. Now, the complex numbers are any numbers that can be written in this form. Let me write that down. The complex numbers are any numbers that can be written in the form A plus BI. Okay? Now, what is I? There's a question. What is I? I stands for an imaginary number or unit. I stands for an imaginary number or unit. Okay? And imaginary numbers are used when no real solution can be found. Namely, when we try to take an even root of a negative number. So when do we use imaginary numbers? Is when we try to take an even root of a what? And a negative number. You guys may remember that this was one of the conditions that caused the domain issues for us in the early lessons. So let's see, what is the value? Here's another question. What is the value of I? Right? Let's do that. So I, let me just show you. I squared is equal to -1. And I'm just gonna show you why is this, okay? First, what is the opposite of squaring? We said, remember the opposite of root is square rooting was squaring. Now the opposite of squaring is square rooting. So let me write down the question. What is the opposite of squaring? Remember that we said was square rooting, and when we were asking the lessons before, is what is the opposite of square rooting? Squaring. Okay. So we have I squared equals to -1. So if I square root both sides, what do I get? So I is going to be equal to what? To the. So this is going to become useful when taking the square or even root of a negative number. Okay? This is, oh no, this will become useful when taking the square or even root of a negative number or quantity. Sorry, negative number or quantity. It would be very useful. And let's do the exercises. So we have the first example that we have. It says, so first, what we're going to be doing is we're going to separate this into the product of two radicals. We will separate this into the product of two radicals. Okay, so let's do that. So this is going to be equal to what? The square root of 4 times the square root of -1. Okay, we know that the square root of 4 is 2. And what do we find out about the square root of -1? Is I. So this is going to be equal to 2i. Now, because complex numbers are written as a plus bi, the I is going to be always be the last one. So just gonna write it here, that because complex numbers are written as what? Remember what we said, a plus bi. So then I is last, just like we did it there. Now let's go to the next one. -7. So what do? We're going to separate this product into, we're going to separate it into the product of two radicals. So this is equal to square root of 7 times -1. We don't know the square root of 7. We know that this is equal to I. Okay? Let's do one more. Look at this one. We have negative minus negative, -18. So we could divide this in two, right? So we know this is 9 times what? -2, right? But we could divide this one in what? 2, make it in the product of two radicals, -1. So what do? Square root of 9 is 3. Square root of 2, we don't know. But we know this one is I. This is I. So in this case, the I is not going to go right here at the end, because we need to make sure that the I does not look like part of the radical. If we leave it, put it here, it's going to look like it's part of this. That is part of the radical. Okay? The radical. That's what it happens here. So we're going to leave it like that, this notation. So let's write this down. This is the preferred notation. Because we want to make sure the I, to make sure the I does not look like part of the radical. Meaning we don't see it, we don't think it's going to be part of the 2. Okay? Now, we're going to try to multiply now. Okay? So, there it is. Now we're going to try to multiply and divide. And dividing, okay? We're going to try both. So we have, here's the example. We have negative 5 square root of 5 times negative 6 square root. So you might think that we're just going to have to combine the radicands, but that's not how it works, okay? So they are both imaginary, and we're going to keep them separate. So let me write that down. That way we remember that we cannot do that. So you might think you should just combine the radicands, right? To get 30. But this is not how it works, okay? We cannot do it like that because we're gonna, guys, recall that we said the square root of A times the square root of B, it was equal to, as long as A, square root of A and square root of B are real numbers, and these ones are not, okay? As long as square root of A and square root of B are real numbers. So because they are not, we're gonna do how we're gonna do it? We're going to keep them separate. They both are imaginary. So since it's negative 5 and square root of negative 5 and square root of negative 6 are both imaginary, what do? We keep them separate. That's what we're doing. So let me get this ready. So we're gonna have, this is what we have. So we're gonna do the first one. It's gonna be square root of 5 times, negative 1, sorry, and square root of 6 times square root of negative 1. Okay, so what do we get here? We get an I from here. This is a 5, sorry. Then we get another I, right? So what do we have here? Now we can combine it. It will be square root of 30. One I and another I. What do we get there? This is I squared. And what did we say at the beginning that I squared was? What did I write it down? Negative 1. So we need to keep in mind that I squared is negative 1 and I is square root of negative 1. Okay, so this is equal to negative 1. So my answer is going to be negative 1 times 30 or negative 30. Okay. Now I have more exercises that we can try. Let's do this example. So what right? So this is I, this is 1, and this is I, right? So what do we have? Negative square root of 9, I squared. What's the square root of 9? Is 3. What is I squared? We said this was equal to negative 1. So this is, my answer is going to be negative 1. Okay, let's do another one. Um, 325 times square root of negative 5. All right, so we know that 125 is what? 25 times 5. So let's divide it. Square root of 25 times the square root of 5, right? Now, this one, square root of 5 times square root of negative 1. Now, this is 5. This is going to be 25. And this is going to be I. Don't forget that. So what do we have here? Square root of 25 is 5. So my answer is going to be 25I. Okay. Let's go to the next one. Look at this one. Square root of negative 27 over the square root of 3. Now, we could divide this one, right? Square root of 9 times the square root of 3 times negative 1 over the square root of 3. What happened there? Make a 1, right? And what is this? This is negative 1. So what do I have? Sorry, this is I. So what do I have? A square root of 9I. And this is equal to 3I. Okay. Now we're going to start adding and subtracting complex numbers. That's what we're going to start doing. Okay. And we were multiplying and dividing. We're going to add and subtract. And what do? We combine like terms. That's what we do. Okay? And let's do the first exercise. It says 3 minus 5I plus negative 4 plus I. Here we go. So I'm just going to take the parentheses, okay? So this is going to be 3 minus 5I minus 4 plus I. Nothing is going to change here because we have a plus sign. So let me combine the like terms. So the first one is the 3 minus 4, which is going to be negative 1, right? And the other one will be minus 5I plus 1 will be negative 4I. Remember that we need to write it in this form. So I'll show you the form. Remember to write in the form what? A plus BI. Don't forget that. It needs to be in that. So another one. Number 2. 4i minus 3. That's what we have there. So now, if I take this parenthesis, this number is going to become negative, and this one is going to become positive. Okay, remember, it's like I have a 1 here. So it's going to be 4i minus 3 plus I. So here's my number. I cannot combine it. 4i plus 1i is going to be 5i. And it's in this form, a plus bi. Now, let's do another one. We have negative 5 minus 2i, negative 8. So be careful there. Right now we have a 1 here. Negative 1 times negative 8 is positive 8. Okay, so if I combine the numbers, it's going to be 3 minus 2i. And we have it in the a plus bi form. I have one more here too. 2 minus 5i minus there we go. So again, that's going to be negative 5 plus 2i. So if I combine the numbers, what do I get? Negative 3. And if I combine the I numbers, I get 3i. That's my answer. Okay. Now we're going to get multiplying more. Let's do some more of that. So the next one is going to be negative 4i times 5i. That's what? It's going to be negative 4 times 5 is 20. I is squared. What did we say I squared was equal to? Negative 1. So my answer is going to be 20 positive. Okay. Now, we have 5i times 2 plus I. Okay, we're going to distribute that. That will be 10i. And this one will be 5i squared. So we have 10i plus 5. And what is this equal? Negative 1. So we need it in the form a plus bi. So it's going to have to be like this, remember. A plus bi. Okay. Now, let's do number let's go to 7. We have 2 plus 3i. So let's distribute that. 2 times 6 is going to be 12. 2 times negative I is 2i. This is going to be 18i. And this is going to be 3i squared. Let's see, what can I, is there anything that I can combine there? Yeah, it's going to be this one and this one. So this is 12 plus 16i. And what did we say this one was equal to negative 1? So this is going to be plus 3. So now we can combine this one and this one, the two numbers. So it's going to be 15 plus 16i. Again, a plus bi form. Don't forget. Now, look at this one. 3 minus I squared. Okay. So we know that this is going to be equal to 3 minus I squared times 3 minus I squared, right? And this is going to be 9. This is going to be 3i, negative 3i, negative 3i, and positive I squared. If I combine these two, I get 6i. And what do we say this one was? Negative 1. 9 minus 1 is 8 minus 6i. Again, it's in the a plus bi form. Okay? And I do have one more thing I need to. Okay, so we have 9 plus 2i times 9 minus 2i. Okay? So let's multiply. We have 81 negative 18i positive 18i negative 4i squared. So what is going to happen here? We're going to make a 0, right? Now, what is this? Equal to negative 1. So it's going to be 81 plus 4. And 81 plus 4 is 85. So, look what we just did here. We multiplied two conjugates, right? Two complex conjugates. That's what we just did. And what happened there? The middle terms disappear, as they always do with conjugates. And in this, and one more thing that we need to add with imaginary numbers, that the imaginary parts also disappear. Okay? So what happened here when we multiply complex conjugates, that the middle terms disappeared, as they always do with conjugates. All right? And the imaginary parts disappear too. We don't have any more imaginary parts, okay? So, in fact, we could say we can say that this is equal to a squared plus b squared. And this is the sum of the squares. The sum of the squares was prime on the real number line. The sum of the square was prime on the real number line. And I have another exercise that we could do. So we have a minus bi times a plus bi, right? We know that, and we know that this is a squared plus b squared. Now, let's do this example. If we want to, we could just go ahead and do this. A is squared and negative 2i squared, or 2i, so this is going to be 64, and this is going to be 4i squared. What is 4i squared? Negative 1. You know what? I don't know why. This needs to be negative. So we are going to do it as we've always been doing. 8 times 8, 64. 8 times 2, 16i. Negative 16i minus 4i squared. Again, what are we doing there? Make it 0, right? So what we have left is, remember, this is what? Negative 1. So it's going to be 64 plus 4, and that's going to be 68. Okay. Now we're going to be dividing. So let's do a division. So we are going to be dividing with I, okay? Dividing with I. So it says that when is conjugate multiplication useful? So when we divide, That's when it's useful. And let me just write down a question. When is conjugate multiplication useful? And the answer is when we when we divide. And we're going to start doing examples, and we need to write them in the form of a plus bi. So here's are the examples, and it says write in the form a plus bi. Okay, so the first one, this one, we have a 2 plus I divided 1 minus I. So we need to multiply it by the conjugate of the denominator. That's what we need to do. And let me write it down there. So it says multiplied by the conjugate of the denominator. That's what we need to do. So we're going to do that. Let's do it. So we're going to multiply it. First, let's do how we always do. That we multiply by 1. But we know that multiplying by 1 means that we are going to multiply by the conjugate, which is going to be 1 plus I. 1 plus I. Okay? This is R1. So let's do the multiplication. So we have, that's going to be 2 plus 2I plus I plus I squared. That's on the top. Bottom is going to have 1 plus I minus I minus I squared. Right? So we know we're going to just combine like terms, right? So let me combine these two. So we get 2 plus 3I. And what do we get of this one? Negative 1. Negative 1. Down here, make a 0. So we're only going to have 1. And what is this I squared equal? 1. Negative 1. So negative 1 plus negative 1 negative 1. Yeah, that's what it is there. That would be plus 1. These two negative. So the top we have 2 minus 1 is 1 plus 3I divided by 2. But remember, we need it in the form A plus BI form. So we're going to have to first this one and then this one. Okay, so it's going to be 1/2 plus 3/2 I. That's in that Now, let's do another one. Yeah, I have a few more that we could do. So let's do this one. We have 4 plus 3i divided 3 minus 4. The conjugate of the denominator, right? Multiplied by the conjugate of the nominator, okay? So we're gonna do that. So we have 4 plus 3i minus 4i. So here's the conjugate, 3 plus 4i and 3 plus 4i. That's what we're doing there. Now, let's multiply that. That's gonna be 12 plus 16i plus 9i plus 12i squared. And this one is 9 plus 12i minus 12i minus 16i squared. Okay, so we know we're making a 0 here, right? And we're gonna combine these two, and we know that this one is -1. So let's do all of that. So we have 12 here minus 1 plus 25i. Sorry. Oh, sorry, minus 12 divided by, this is -1. So it's gonna be, sorry, 9 plus 16. So again, here we make a 0. So what we're gonna have is 25i divided by 25. And we're making a 1 here. So my answer is gonna be just an I. Okay? And I do have, let's try another one. We're gonna try when we don't have a binomial in the denominator. Let's try those now. So this is what we have now, 7 over 3i. There's no conjugate, right? So we're gonna multiply by the opposite. Let me write that down there so I have it. There's no there's no conjugate, so multiply by the opposite. All right, so that's what we're doing. So we have 7. Remember, it's like multiplying by 1. So we're gonna say 7 over 3i. What's the opposite? -3i over -3i. Okay? And what do we get? -21i. And here we get negative 9i squared. But what is I squared equal? Negative 1. So what do I have? I'm going to have negative 21i divided by 9. Now, we could simplify this. 3 goes 7 times and 3 goes 3 times. So my answer is still going to be negative 7i divided by 3. Or we could multiply the denominator as is. So let me do it that way. So we could do it this way, or different color. We could multiply the denominator as is, okay? So let's do it that way. So this is 21i, this is 9i squared, 21i, negative 9, what do we get? Negative 7 over 3i. So it is up to you. So we could multiply or multiplied by the denominator as is, okay? It's your choice. We get the same answer. What we're trying to do is to get rid of the I in the denominator. So that's why we could use either this method or this one. Either way, we're trying to get rid of the I in the denominator. That's what we're trying to do. Now, let me do this one. So we have 5 plus 3i divided by 4i. Okay, so what do? I'm going to multiply by the opposite. Remember, you can multiply by 4i too. So what do we get when we do that? Where do I do it here? That's negative 20i minus 12i squared over negative 16i. I squared. Now, this is negative 20i. Where is this? Negative 1. Negative 16 times 1. Okay. This is equal to negative 1. So what do we have left? We have 20i plus 12. And we have 16 positive. Remember, we need it in the a plus bi form. And this is not in that form. So let's do it. Let's change it. So we have 12 over 16 minus 20i over 16. I'm just distributing the 16. Divided by 4 is 3 over 4. And divided by 4 is 5 over 4. So this is going to be my answer. And it's in the form of what? A plus bi. Okay, now the last part that we're going to be talking about is the powers of I. Okay? Yeah, the powers of I. So we have um, powers of I. And we have, it's asking us to evaluate the following. So I'm just going to do a few of them. Evaluate the following. So it's giving us the first one is I to the second, I to the third, I to the fourth power. Let's do this one very quick. So this is I. We know this one is what? I times I squared. So this is I, and this is what? -1. So it's going to be negative I. And this one is going to be I squared times I squared. -1 times -1 is +1. And we're going to remember this one. This is the one that we're going to remember. But let me just do the other ones. 5 is I to the 5, I to the 6, I to the 7, and I to the 8. So this one, I to the second. So what do we have? -1 times -1, that's going to be 1 times I. 1, 2, and 3. -1 times -1 is 1 times -1 is -1. And we have exactly the same one, but we need to add one more. So it's going to be -I. And this one is going to be 1 positive. Okay, so then we're going to use the fact that I to the 4th power is equal to 1. And we're going to rewrite a power of I in terms of I to the 4th. That's what we're going to be doing. So we're going to rewrite powers. This is the one that we're going to be using. I to the 4th, we know is 1. So you know that I to the 8th is 1. I to the 12th is going to be 1. I to the 16 is going to be 1. Now, let's say we have, I have another ones here. 9. I to the 9th would be what? We are going to be using this one. We said we're gonna go by this one, okay? We will use the fact that I to the 4th power is 1. And we're gonna rewrite a power of I in terms of I to the 4th power. That's how we're gonna do this. So this is I to the 4 and I to the 4 times I. So this is gonna be what? I, right? There we go. Now, the next one. I, oh, 39, 34 to the 34 power. So this is going to be what? 32, right? Because 4 goes into 32. 8 times 4 is 32. and this is a 2. So this is 1. We know this is 1. And we know this one is what? -1. So my answer is going to be -1. Now, that's 34. Oops, 86, sorry. It's 86. So we know 4 goes into 84. 21 times, right? And so this is exactly the same answer. We could say 72. I to the 72 power. Not 72, 75, guys. 75 times what? I to the third power. So what do we get? We get a 1 and what is I to the third power equal? Equal to -I. So my answer is going to be -I. If the exponent, just like I was writing here, if the exponent is a multiple of 4, so my answer is going to be 1. Okay? That part we know. If it's 4, it's going to be 1. We could have examples like this in case negative I to the 42 power. Okay, so here's the negative I to the 40th power, right? Times I to the second power. So we know this is 1. And this is -1. So what do we get? A +1. Okay? And we finally done the chapter 8.